So I have concluded creating a confidence interval using a z-distribution, and I'll be using the same particular kind of data to create a confidence interval using a t-distribution this time. So this time, let us suppose the same data is there. There are probably 1,000 students in that particular university once again, and I have got a sample of 20 students, and their average marks in the test of statistics are 50 with a, and I calculated a standard deviation from the sample only, and it comes out to be 10 marks for me. So since I know that sample is small because it is less than 30, and there is a sample population under standard deviation is unknown, so I'm going to use a t-distribution this time to calculate the confidence interval. Let's do that, and I understand the formula for that is P of x bar minus T alpha S by square root n less than equal to population mean, and that is going to be x bar plus T alpha S divided by square root n, as I discussed earlier, and that is going to be 1 minus alpha. So since alpha I'm taking here as 0.05 for some reason, that means there is a 5% level of significance. The catch is to calculate the T alpha. So you can see my t-distribution tables, and if you want to calculate T alpha value, then I need to know the degrees of freedom, which is always equal to sample size 1, and I have a sample size of 20 here, and hence my degrees of freedom becomes 19. And if you see the structure of T table, then I have degrees of freedom. I should go a little straight listed here, 1, 2, 3, and so on. So I'm going to see the 19 degrees of freedom here. And there are alpha's values which are listed here. So I'm going to see 0.005 here. And when I see this particular intersection here, I'll find something called 1.732. So that's how do you see the T table with 19 degrees of freedom. Let me get rid of this extra line. It looks really bad. Okay, fair enough. So that's how you calculate the T alpha value. So for me, T alpha value here is 1.732. And we use a different color to quickly create the confidence interval. Okay. And now the thing seems pretty simple to me. X bar is 50 and minus T alpha value, which is 1.732. And I have a standard deviation of 10 square root of 20 less than equal to mu less than equal to x bar, which is again, let me clean it up again. I keep on doing these silly mistakes. That is again 50, and that is going to be plus 1.732 times 10 divided by square root 20, and 1 minus alpha here is going to be 0.95. And if I do some arithmetic here, then I'm going to get something like 46.13 less than equal to mu less than equal to 53.87, and that is exactly equal to 0.95. So I can say that I'm 95% confidence. You can also write it, let's say 95%. So probability of this scenario to appear, that means probability that population marks or marks of all 1,000 students fall between these two limits is 95%. Or you can say that if I pick up a small sample, then 95% of the samples are going to represent the population mean. Or one other way to say is if randomly pick up a student from a small sample, then there's a 95% chance that his marks are going to be between 46.13 and 53.87. So that's how you create confidence interval using a t-distribution and a z-distribution. In next lecture, I'll be talking about Excel solutions to this. Thank you.